Let's learn how to expand sine x into its Maclaurin series. The Maclaurin series is a special case of the Taylor series centered at x equals 0. The Maclaurin series formula states that a function f of x equals the sum from n equals 0 to infinity of f's nth derivative at 0, divided by n factorial times x to the nth power. Let's find the derivatives of sine x and evaluate them at x equals 0. The first derivative is cosine x. The second derivative is negative sine x. The third derivative is negative cosine x. And the fourth derivative is sine x. Do you notice the pattern? The derivatives cycle every 4 times. Now, let's evaluate each derivative at x equals 0. Sine of 0 is 0. Cosine of 0 is 1. Negative sine of 0 is 0. Negative cosine of 0 is negative 1. And this pattern continues. Let's substitute these values into our Maclaurin series formula. The first term is 0. The second term is x over 1 factorial. The third term is 0. The fourth term is negative x cubed over 3 factorial. This pattern continues, giving us terms with only odd powers of x, alternating between positive and negative. Finally, we can write this series in a compact form using summation notation. Sine x equals the sum from n equals 0 to infinity of negative 1 to the n power, times x to the 2n plus 1 power, divided by 2n plus 1 factorial. Let's visualize how this series approximates sine x. The blue curve is the actual sine function. The orange curve shows the first term, x. The green curve adds the second term. And the red curve adds the third term. Notice how each term improves the approximation. And that's how we expand sine x into its Maclaurin series. The more terms we include, the better our approximation becomes.